So besides our Pythagorean identity, so the sine squared plus cosine squared equals 1, your double angle theorems are actually the theorems that you see most often if you continue into higher math classes. So because we're not spending a ton of time on these, okay, I am going to give you the double and the half angle on your test, okay, but you do still need to know how to use them. So I would go ahead and write those down because you also need them for your homework. So sine of 2u is equal to 2 sine u cosine u. Tangent of 2u is equal to 2 tangent u divided by 1 minus tangent squared of u. And then cosine of 2u, we actually have 3 different formulas that it can equal. Let's look at an example. So one way that we can use these identities is just like we've been using our other identities, is to simplify stuff. If I look at this, hopefully we notice that we have a squared. Yes. And in the past when we've seen squared, we wanted to use our Pythagorean identity. Okay. But we only have a cosine squared. So like even if we switched it to sine squared, it wouldn't be super helpful because you would still have a something squared there. Does that make sense? However, remember when we've been talking about our factoring, what's the first thing that we want to look for in some of our things?
Refactoring?
Yep. We would see if they have a yep. And so in this case, what is their greatest common factor? 2. Now, be careful here, because if I factor out a 2, remember, factoring is like dividing something out. Yes? So if I divide -2 by 2, what am I left with? -1. Okay, because I had some people on our concept check last week that whenever you were factoring out, like if whatever was here is whatever we factored out, you just didn't put anything. Okay, but I have to put a placeholder of a 1 there, because if we don't, it throws off the rest of it. Yes, so maybe. So now, does that inside look like something?
Yes.
Yeah, what's it look like? Yeah, so it's in our formula it's 2u. U is just a placeholder for whatever variable we have. In this case we have an x, so now I have 2 cosine of 2x. Which would be nicer to deal with because now I don't have subtraction and I don't have a squared, right? We were able to condense that down to just cosine 2x.
Wait, how did you get there?
I used my cosine 2u formula.
Okay.
So basically like this is on the left side of your formula, this is on the right side of your formula. So I'm just substituting. Does that make sense? Because if they equal each other, then I can replace one or the other whenever I want.
So for that formula, like all the stuff that it equals equal cosine 2u.
Correct. Yes. Okay. All 3 of these equal cosine 2u. because otherwise it would take too long. Okay. So notice that we are given cosine of theta. Yes? As 5/13. Now, be careful here, because a lot of people's instinct is they see a 2 theta here, like on the cosine, and they just want to multiply that by 2. Okay? Except that would be if I had 2 cosine of theta. Okay, that would be me just multiplying the fraction by 2. I want to multiply the angle by 2, which is not the same thing as just multiplying my fraction by 2. But do I know what my angle is? I know what the angle is? No, because it's just a theta, right? Like theta is just a generalized angle, and I don't know what it is. Okay. I do know where it's located. What quadrant is it in? Four. That's going to be helpful here in a second. Okay. And so the purpose, if I wanted to find sine of 2u, is then if I'm given cosine of theta, I can use our double angle formula to plug in. Because notice on the right side here, these are just thetas. So as long as I know cosine of theta and sine of theta, I can find sine of 2 theta. Now, do I know cosine of theta? Yeah, they gave it to us. Do I know sine? No. But we can find it. Because remember, cosine is equal to what? Yeah, so of a right triangle, yes. So this would be my adjacent and my hypotenuse, yes. And sine of theta is equal to the opposite over hypotenuse, right? So I just need to find my opposite side now, and we can find our sine. Agreed? How would I find my opposite side there? Yep. So what do we have to be careful about?
The 13 is the hypotenuse.
Yeah.
So it goes on the other side of the.
So it has to be our c squared, yes? I'm going to make this b squared. So I have b squared plus 25 has to equal 169. Yes, no, maybe? Okay, so then how do I solve for b?
Subtract 25.
And?
Square.
Not square it.
Or the square root.
Square root it. There we go. So I get 12. Which means that what is sine? Yep. So opposite now is 12. Our hypotenuse is still 13. So we know that that is 12 over 13. So notice that 2 times 5 gives us 10 times 12 gives us. So 10 times 12 gives us 120. And then 13 times 13 we said is 169. Yes?
Did you just like solve all of that?
Did I just what? I just multiplied. So like I did the 2 times the 5 first because 2 times 5 is 10, so that makes it a little bit easier. So times 12 is 120, and then 13 times 13 is 169. Which notice 120 over 169, okay, is not just going to be doubled stuff, right? Then next, what do we need to find? What's the second thing it asks us? That was sine, so now we need to find cosine. Okay. And remember, we have 3 different formulas that we can choose from. And you can choose any of them. Okay? Now, I will say that usually I tend to stick to like whatever they give me. Okay? So they gave us cosine, so I'm probably going to use this second one. If they gave me sine, I'm probably going to use the last one. Does that make sense? Okay, so 2 cosine squared minus 1. Yes? And this time it's nice because we don't even have to solve for anything. We just have to plug in 5 over 13. And if we aren't great with fractions, then you can plug that into your calculator. Okay.
Thank you.
Not that fractions are bad, but if we did square that, notice 5 squared is 25, 13 squared is 169. So we get 50 over 169. Finding a common denominator, we get 50 over 169 minus 169 over 169, which would be negative 119 over 169. Which is much different than 10 over 13, right? If I just multiplied by 2. Which is why we have to use our formulas. What questions do we have on either one of those? Okay, those were our double angle. We also have some half angle. Now, the hardest part with these ones is figuring out what your U is. So, like on this next one, it says find the exact value of sine of 105 degrees. What does exact value mean? Does that mean I can round it? So does that mean I can plug that into my calculator? No, because I'm going to get a not nice, very pretty decimal approximation, right? Which is not what exact value means. So do not do that on your test, okay? But what do we usually use to find the exact values of sines and cosines? Thing that we've been using for like 3 units now. The unit circle, yeah? The only thing is 105 on my unit circle? It is not. Okay? However, let's think about if I double it, what do we get? 210 is 210 on my unit circle.
Yeah.
Yes. Okay. But am I allowed to just double it and put an equal sign there?
Cool.
No. But what we could do is we can strategically rewrite it. Do we all agree that we said that if I double 105 I get 210, which means that 210 divided by 2 is also 105. So in this case, I haven't changed the value, I've just rewritten it strategically. Are we all okay with that? And the reason that we do that is because now we can use our formula and our u is going to be 210. Because notice that on the inside of our formula here we just have a u. And since 210 is on our unit circle, I know what we should know what cosine of 210 is. So we can get our exact value now. So we have that. Yes or no, maybe. Now we do need to decide if we want the positive one or the negative one. And remember that all of these have to be equal to each other, so I'm going back to my original to decide. So 105 is in which quadrant? The second, and sine is what in our second? Positive. So I'm going to choose the positive. Okay. So then, let's think about what quadrant is 210 in.
210 is it third?
Yup. Okay, and so then we need to figure out what our reference angle is. And remember, for our third quadrant, we do that by subtracting off 180. So what is 210 minus 180?
It'd be about
30. It's 30 degrees. So now we know that I can use my 30-degree angle. So what is our point at 30 degrees? Which comes first? The 3? Yes? So we get our square root of 3 over 2, comma, 1 half. So what's cosine? Okay. But 210 is in our third quadrant, and cosine is what in our third quadrant?
negative.
Negative. So I'll write it out. So I am subtracting a negative square root of 3 over 2. Yes? No, maybe. And again, it's not the end of the world if we leave our answer like that. We tend to like to rewrite it so I don't have a fraction within a fraction. Yes? So how could I get rid of this divided by 2? I can, okay? But am I allowed to just multiply by 2 because I feel like it?
No.
No. But I can multiply by 2 as long as I do it to the what?
Top.
As long as I do it to the top and bottom, because now I'm technically multiplying by what? Just a 1. And we are allowed to do that. So here, but I do have to multiply it to both of these. So I have to distribute it. So we get 2 plus, well now my 2 on the bottom here reduces. And then on bottom, 2 times 2 gives us 4. Yes? Okay. And then the only last thing is, remember, when we have division, we can separate these because we would have 2 plus the square root of 3, and then what is the square root of 4? 2. 2. So we get that. So that would be our exact answer, which is still not super pretty because I have a square root within a square root, but there's not really a way to get around that, so that's just our answer.
So if there's, since the 4 is on the bottom,
Correct.
which used to be the 3 over 2, it
So we said we wanted to multiply by 2 to get rid of this 2 right here.
Yeah.
So I multiplied the top, so I had to distribute to both of those. but I can't just multiply the top by 2 because that changes the value. So I also had to multiply the bottom by 2. And so 2 times 2 gave us this 4. Is that what you're asking?
Wait, but then why did it equal 2 on the bottom again?
Because remember that if I have the square root of x divided by y,
Oh, right.
that's the same thing as the square root of x divided by the square root of y. So because this is division, I can separate them.
And then the 4.
And the square root of 4
is 2.
is 2. Now remember that that doesn't work for addition and subtraction. So like I can't separate it out if I'm adding or subtracting. But if it's division, we can. Which is nice because we don't like square roots to be on bottom. So that's why it's kind of nice to go ahead and simplify it out.